at the end of the webinar. So with that, I would like to pass it over to Ajay and have him start the presentation. Ajay?
Hi, Kim. Thank you. And welcome, everyone. I'm Ajay. I'm Director of Technical Channels at Hortonworks. And in my capacity at Hortonworks, I work a lot with our ecosystem partners to really create reference architectures that optimize the delivery and deployment of the Hortonworks Data Platform. And I'm truly glad to be participating in this meeting with Sean here from Cisco, because we are very close partners with Cisco. We work very hard to create reference designs that really deliver the Hadoop experience for our customers the best possible way in the market right now. So Sean, before I get started with the slide, do you want to speak a few words about your role at Cisco?
Yeah, thank you, Ajay and Kim. I really appreciate the opportunity to join our friends here at Hortonworks to let everybody know about the great work we've been doing together. I'm a solutions architect in the Cisco data center sales team, and for the last 3-4 years been focused on the big data market, and been working very closely with our customers and our engineering teams to develop and deploy big data solutions, in particular those running Hadoop and Hortonworks in particular. So we're looking forward to being able to go into some detail on the kind of work we've done together.
Very good, Sean. So let's get started with the real content here. Now, what I want to do is spend 5-10 minutes just talking about some of the trends in the big data world, and then I will also cover a little bit about aspects that should be considered as you plan your infrastructure to run Hadoop. And from there on, I will pass the control to Sean, who will speak more about the reference designs and SKUs that Cisco has to offer for big data. So in terms of really what is going on with regards to big data, we are seeing a huge adoption at this particular point in time. Really, Hadoop has come to an inflection point where every industry is embracing Hadoop as a tool in a bag of tools, as not really the only tool, but certainly one of the tools in their bag of tools to deal with the growing volumes of data that they have. And the reason for Hadoop and the reason to put the growing volumes of data into Hadoop is really because we are living in a connected world, right? So as all of us are carrying smartphones, as our buildings have smart sensors, as our cars and machines are getting instrumented, there is just a lot of machine data that is being generated. And the machine data that is generated comes in high volume, comes at high pace, is variably structured, and putting all of that data into traditional data management platforms is untenable as the size of data grows bigger and bigger by the day. So really, the fact that we live in the connected world and this new machine data that is being generated is what's driving the adoption of Hadoop at this point in time. Now, as we look at what are the use cases by vertical, there are a few use cases that stand out, and clearly one of the use cases that was pretty much the bread and butter for Hadoop was being able to collect a lot of data and do batch analytics on top of that data, right? So an example of that will be personalized insurance. So now we can go to auto insurance companies and ask for personalized insurance, in which case they send us a telemetry device that we fit into our car, and the telemetry device basically monitors an individual's driving behavior, and the insurance company prices your insurance based on not just your demographic and your static profiles, but really your real-time, runtime driving behavior, right? So being able to do that batch analytics on large amounts of machine data, that's definitely one of the key use cases of Hadoop. But Hadoop has really grown beyond just being able to do batch analysis of data. Very much people want to do interactive analysis of data, so they want the analyst to be able to look at data interactively. And they also want to be able to do real-time event processing. And an example of real-time event processing is personalized promotions that retailers want to provide their customers, right? You don't want to necessarily wait to send an offer in an email at the end of the day. You want to capture the attention of the customer while he is on your website, and where applicable, you want to serve the ad and the promotion in line with what the user is doing on your web property. So really, the need to go beyond batch processing to where you can now meet interactive and real-time needs of big data is something that we are starting to see happen in the Hadoop world. And that is also impacting the nature of service and how you lay down your Hadoop infrastructure. So while previously most of Hadoop clusters were running on 24 gigs of RAM, maybe single CPU, 6 cores, increasingly what we see now and what is optimal for Hadoop is a server that is more capable and a network between the servers that is more capable, so you can deal with these evolving use cases of Hadoop. So I'll skip on now. In terms of how Hadoop fits in within your data center, Hadoop is really not about rip and replace, right? Hadoop brings capabilities that is complementary to your existing data platforms. Certainly, there are capabilities in your enterprise data warehouses and within relational database systems that Hadoop does not have. An example of that would be multi-statement transaction controls that Hadoop does not have, right? So it isn't about Hadoop replacing your data platforms. It is about Hadoop sitting next to your data platforms, to your existing data platforms, and bringing additional capabilities to the enterprise as it relates to machine-generated data. Now, one thing that really has come about in the Hadoop world and helped it transition from being essentially a batch platform to a platform that can do now batch, interactive, iterative, and streaming workloads is a new component called YARN. And YARN, it stands for yet another resource negotiator. It is the data operating system of Hadoop, and it got generally available at Apache as part of Hadoop 2 release. So Hadoop 2 release happened at the end of last year. I believe it was October 22nd when it went GA at Apache. And as part of Hadoop 2, YARN was a key component that got included in the Hadoop stack. And with YARN, now you can store all your data in one place and interact with that data using fit-for-purpose processing engine. You are no longer limited to using MapReduce. If you want to do advanced statistical analysis and your preferred choice of tool for statistical analysis is SAS, then you can bring SAS to run on top of that same data that's sitting within your data lake. If you want to do stream processing, you can use Apache Storm to do stream processing, or if you have an alternative stream processing engine that you have a preference for and it's something that you are already accustomed to, you can bring that as well into your data lake. So really, YARN has opened up Hadoop to taking on newer workloads, and that is very much impacting what kind of hardware and what kind of network infrastructure you lay down to build out your Hadoop lake. Now, as you begin your journey of designing the lake, there are certain things that you would have to factor in, which is how much storage capacity I'm going to need. Right. The other thing that you need to think about is what kind of service would I deploy for my data lake. The third question that commonly comes up and one that needs to be addressed up front is what is going to be my cluster size? How big? How many nodes do I need in my Hadoop cluster? And lastly, how do I factor in performance? Right? As Hadoop is evolving from being batch to being interactive and real time, performance SLAs have become more critical now than it was 2 years back. So to be able to address your performance requirements and factor that into your cluster design is a key attribute that would need to be considered. Now, as you are going about designing or understanding how much storage you will need, what kind of service, there's certain things that you should keep in mind. One, that hardware will fail. And when you run hardware at scale that Hadoop runs on, which is hundreds of thousands of nodes, you can be sure that one or the other node will go down sporadically. Now, one thing to keep in mind is as your cluster grows bigger, the resiliency of the cluster to node failures go high, right? So even though your nodes are going down, you just have more compute capacity, and the impact of any node going down is lesser as your cluster gets to be bigger. The other thing to keep in mind also is that Hadoop is very fault tolerant, right? As your nodes go down, you do not necessarily have to rush to the data center and address the problem immediately. Some of the best practices that we see across our customers is they will queue up the work tasks, and they either address all the node failures once a day or once a week, depending upon really how big in their cluster is and how resilient their cluster is due to node failures and the impact of node failures. So now let's dive into each one of these attributes that you need to think through as you lay out your Hadoop cluster. So first one, storage capacity. Now this is actually quite difficult to get a full handle on. Most of the time you will have a very good sense of what is the raw data that you want to connect, that you want to bring into your Hadoop cluster, right? But the typical workflow is that once you bring in your raw data, you combine that data with other complementary data sets to create work-in-process data, to create master data, or some people may call it the golden data. And then from the golden data, even create materialized views that you may feed into data marts or data warehouses. So really, the data set that stays within your Hadoop cluster is more than just the raw data that you bring in. Now, what is going to be the size of your work-in-process data, master data, materialized views? It's really hard to guess it very accurately or very precisely at the start of your implementation. So the recommendation there is really to be conservative. Also, the recommendation is to plan for storage looking out 3 years. So don't just look at how much storage am I going to need now. You should be looking into how much storage would I need 3 years out. And what we have seen with our customers is that once they begin their Hadoop journey with a particular use case in mind, their adoption of Hadoop and the number of use cases that they begin to address with Hadoop expands very quickly. So as your use cases are expanding and as you are discovering newer abilities to leverage Hadoop, you don't want to be in a situation where you simply are running out of storage space and having to add nodes at a time or a rack at a time. That really kind of impedes the pace at which you can use Hadoop to deliver value to your enterprise. So look 3 years out. Also, always keep in mind that you will have intermediate data sets and master data sets that you would need to account for within your Hadoop cluster. Okay, so if we try and boil it all down to a simple equation, it really comes down to how much storage do I need? It's what's your initial size that you anticipate to bring in? What's your year-over-year growth? What's your intermediate data size? Again, this is a little rough to estimate. It's a little difficult to estimate precisely up front. What's going to be my replication count? So Hadoop replicates to get high availability. And Hadoop also needs some temporary space to store intermediate data that it requires for doing its computation. And typically 20% extra space is recommended for that intermediate data. And finally, when you store data in Hadoop, you're always recommended to compress the data. Compression helps you get more out of the storage capacity that you have. Compression also helps with speeding the performance because it's faster to read the data out of the disk when it is compressed, right? And some of the good rules of thumb is keep your replication count to 3. 3 is the default for most Hadoop distributions. It is the default for Hortonworks Data Platform. It gives you a good balance of resiliency and availability and performance. Now, there are certain cases for where you may want to up the number of replication count. So, for instance, if you have a dimension table that you want to join with fact tables, you may be better off by having multiple copies of that dimension table, and you can do so by increasing the replication count beyond 3. We don't certainly recommend for you to have replication count of less than 3 because it exposes you to data unavailability in the case of disk failures. For compression ratio, the mileage really varies. On average, we see 4 to 5 across our customers. Again, you should look into your data set to really understand what kind of compression can you get. If it's binary data, i.e. audio files, video files, you would not get much of any compression. If it is text data, especially text data that has lots of repeated values, it is very common for our customers to get anywhere from 10 to 20x compression. So really your mileage will vary depending upon the kind of data you have, and a good rule of thumb is to assume for it to be 4 or 5. And as to the intermediate data size, which I was saying is tough to estimate precisely, again, a good rule of thumb is to estimate for it to be about 50 to 100% of your raw data size. Now, one thing I must say over here is that even if you are creating your golden data, right, by combining the raw data and processing the raw data into more valuable sets of information, what we recommend and what our customers always do is retain the raw data, right? You never drop your raw data because that helps you. That is fact as you have collected, and by retaining the raw data, you always have the ability to go back and reprocess to get newer insight that you may not have quite comprehended and or factored in at the time you were doing your initial rollout of the use case. And 1.2 I talked about is the additional storage space that Hadoop needs for running through its computation. So much for how much storage do I need. The next question that you commonly would have to address is what is the kind of server that I need to deploy? And here is where kind of earlier topic that I was talking about, where Hadoop has gone beyond just being a batch platform to being more interactive and real-time platform. What we are now seeing is server specifications that are not single nodes, but really dual Intel Xeon E5 2600 series processors for both master and worker nodes. Now, what specific version of 2600 series you're going to choose is going to be contingent on whether your workloads are more performance-centric and or your workloads are more batch-centric. Again, from a memory footprint perspective, the amount of memory on both worker and master nodes are now anywhere from 128 gigabytes to 250 gigabytes. And from a storage perspective, that's where we see a bit of a differentiation between master nodes and worker nodes. Worker nodes is where all your data actually gets stored. Master node is more about coordination services. So the amount of data that you need on disk for master nodes is smaller than what you need on the worker nodes. Now, on the worker nodes, we are seeing that right now anywhere from 1 to 4 terabytes and 12 to 24 disk configurations, depending upon, again, what is the nature of workload that you want to run on your cluster. Now, while over here, I am highlighting that master nodes and worker nodes, the amount of storage they need is different. What is also, I should also state that for many of our customers, they find the convenience of keeping both master node specification and worker node specification the same, easier to manage and easier to administer than keeping them of different profiles. So while the needs are slightly different from a management and operations perspective, it is very common of our customers to have homogeneous nodes across master and worker services. Okay, so now that we have figured out how much data do I need based on our discussions of storage requirement, we have talked about what is the kind of server that I need. You can really compute what is going to be the cluster size, i.e. how many servers do I need. And the answer is really quite simple, right? How much total storage you need divided by storage per server. And storage per server, as I said before, can be anywhere from 12 terabytes to 48 terabytes, depending upon the kind of workload you want to run on the server. Now, as to the number of master nodes, the number of master nodes is typically going to be 2 or 4 for small and moderate size implementation. So what is a small implementation? A small implementation is half a rack. A moderate size implementation is anywhere from 1 rack to 200 nodes, which will 200 nodes. And as you go beyond 100 nodes, you may need more than 4 master nodes. How many more master nodes are you going to need? What master services you're going to run on those master nodes? It's really something that you would have to learn of the implementation and of your own usage. So there is no really fixed guideline that we can provide. What we recommend of our customers is to begin with either 2 or 4, depending upon whether you are small or medium size cluster, and then learn of how your cluster is behaving and add further master nodes as needed. And typically, people get to that point once they go beyond a 100-node cluster. Okay, and the last point that I would like to highlight here before I pass the ball to Sean to really kind of dive into the reference configurations that Cisco makes available for Hadoop workloads is really how do you factor in performance. So one of the things that you can do very much upfront is make a decision on how much storage are you going to have for every drive in your cluster. For clusters that need high performance, the recommendation is to go with 1 terabyte drives, and you could have 12 or 24 of those on each node. For clusters where you're typically going to be doing batch analytics and or archiving use cases, there we see people deploying 4 terabyte drives on each node and 12 of those. So you have either 12 or 24 terabyte capacity on each cluster on each node, and or you have 48 terabyte capacity on each node. Now, that still doesn't give you a complete control or a complete understanding of whether you are going to be meeting your SLA requirements or not. And if you really have a very stringent SLA requirement, either because you are doing online serving of ads and or you're intercepting credit card transactions to act on it in real time, what we would recommend for you is to set up a small cluster, and a small cluster could be a single rack of nodes, and experiment with your use case, experiment with your data, experiment with your use case, and once you have figured out the right amount of data in that single rack deployment, you can then scale it out, knowing that Hadoop scales linearly, right? The good news here is that Hadoop scales linearly, so the experimentation that you would do on a single rack, you can easily scale that out to meet your full data needs and to meet your full SLA requirements. So that's all I had for my piece of the presentation. Again, I'm going to be looking for Q&As. I'll be here for Q&A at the end of the session, and I will want to pass this over to Sean now to specifically talk about Cisco and the SKUs that they bring to the table. Oh, one final point. Again, I had referred to this in the start of my presentation, which is Cisco is our premier data center partner, and both Cisco and Hortonworks are tightly integrated into your data center ecosystem, whether it's management framework, whether it's your network fabric, whether it's other ecosystem partners from a software perspective. We have both partnered with a lot of same companies, and that really kind of adds value to people who deploy Hadoop and Hortonworks Data Platform on the Cisco hardware. Okay, so with that, let me pass it on to Sean. Sean, you want to pick it up?
Yes, and thank you very much. I appreciate it, Ajay. That's a great intro to what we're going to dive into here with respect to the Hortonworks and Cisco validated design for Hadoop. And right off the bat, just to make it real clear, Cisco sells servers, and that may be news to some of you out there. Most people associate Cisco still with the network side of the house, and that's certainly true. But Cisco entered into the server market about 5 years ago. So we sell x86 servers, Intel chips, integrated with our networking and management framework, and it's called Cisco UCS, Unified Computing System. So that is what we're going to be talking about here today. We've designed a reference architecture with Hortonworks running on top of Cisco UCS, Unified Computing System, to deliver Hadoop for our customers and help them integrate that infrastructure into their data center environment in as seamless a fashion as possible. And so we're going to go into the detail of what that architecture looks like and some of the features and benefits that it provides. Starting out, just as a plug, I would encourage folks to go ahead and hit cisco.com/go/bigdata, and there you will find a link to our validated design for Hortonworks. So we've spent lots of time with Hortonworks in our labs, testing their product, their software, running on this reference architecture. There's a detailed document, the one I'm showing here, the CVD, Cisco Validated Design. It's 100+ pages of step-by-step instructions on how to install and configure both the hardware and the software, operating system, Hortonworks, the whole bit, end-to-end. So you've got a great blueprint there to begin your foray into the world of Hadoop. What is this architecture built upon? Okay, well, the building blocks are essentially our C240 M3 server. That's a 2-socket server, Intel CPUs, with option to configure that with between 12 and 24 drives. Very, very similar to exactly what Ajay was referring to earlier with the kind of options you might need, and I'll go into that in a bit of detail on the next slide. So that is the building block. That's the Lego brick, the data node there. And that attaches to our fabric extenders. Those are top-of-rack switching devices that provide the unified fabric for the entire cluster. And then from there up into our what we call our fabric interconnects, and these are essentially Cisco switches with some additional management capabilities built in to manage not just the network but also the compute underneath those switches. So we'll go into a bit of detail on exactly what that means. So that's the architecture. We call it our common platform architecture for big data, and that's the detail that we're going to dive into here. With those components, we've established a number of different single SKU bundles for Hortonworks application environments. As you see here, we're not going to drill into every last component of these bundles, but rest assured, we are offering a number of different choices for different workload types based on the kind of criteria that Ajay described in the beginning. And essentially what it comes down to is we give an option here between performance on one side of the spectrum and price per terabyte on the other. And the idea is, depending on your workload, depending on your needs, and very roughly this equates to archival versus kind of more real-time use cases. And on the archival side, your driving purchasing factor tends to be the price per terabyte component. Whereas with a more real-time workload, customers tend to be more performance-driven. So what we're offering here is kind of a spectrum of choices along those lines to be able to tune to your particular needs and find something that works well for you. And we find that really probably 70, 80, 90% of our customers fall into one of these buckets very comfortably. So before I go into exactly how this all works well for Hortonworks and for Hadoop, I do want to touch on two specific unique attributes of the UCS infrastructure. That is, these are very different from really any other kind of computing environment that you may have been exposed to before. And the first is a concept called a service profile. So what is that? Well, when we built UCS, we set out to solve a problem with installing and managing bare metal physical servers, right? The very first step before you even get an operating system or maybe a hypervisor installed, before you ever get there, you've got to do a whole lot of heavy lifting to get the systems, the physical systems, ready for that process. And there are a number of different configuration items down at that physical level that you have to deal with any server installation, the laundry list I'm showing here. You don't necessarily have to touch every one of these on every single server install, depending on the configuration of the server itself, but a lot of them you do. And these are, again, kind of below that operating system level. And they create state in the server, these items. MAC addresses, VLAN IDs, you got firmware versions, worldwide port names if it's on a SAN, things like this that are kind of baked in down in the physical hardware. And if you get them wrong, you cause yourself all kinds of pain later on down the road trying to run your application. Furthermore, trying to maintain these kinds of things in a large environment is a painful exercise. So what we did with UCS was to essentially abstract all of those items that are normally physically tied to the server and pull out that state, decouple it from the physical, and store that information in what we call a service profile, which is essentially an XML file that we keep up in that switching element, the fabric interconnect. And there, once you've abstracted, once you've decoupled, now you are completely changing the way you deploy and manage a server. You're able to maintain the server's identity in sort of a virtual state, if you will. You have this XML file which you can modify and copy and paste and create templates from, so that when you go to deploy a server, you do it all through software effectively and then push the identity down to the physical box when you're ready to deploy. And the same goes when it's time to replace a failed server. You bring in a new one. It doesn't matter what that new one comes with from the factory in terms of firmware versions or BIOS settings or MAC addresses or anything like that. We kind of overwrite all that when it comes time to provisioning. You provision in software and push the identity down. So that's a common principle of UCS, and we'll build upon that as we get into the Hadoop-specific discussion. The second technology I want to introduce is called our Virtual Interface Card, our VIC. And effectively, this is a network interface card, a NIC, a physical card that is inside the server, walks, talks in a lot of ways, acts like a typical 10 gig Ethernet 2-port NIC. However, there's some special sauce in there. What you see on the left is that kind of standard physical approach to things, a server, an adapter, the various, the port, the cable moving up into the switch. What's interesting about this card, though, is that we can, through the power of this management framework, configure on the adapter itself virtual adapters, kind of sub-adapters, if you will, that are presented to the BIOS and therefore to the operating system as real, as physical adapters. As far as you're concerned on the operating system, you see exactly what Cisco UCS Manager tells the server to see. So if you need 3 NICs and 4 HBAs or 2 NICs and 5 HBAs, whatever combination you need, that's what the operating system sees on boot. And all of that traffic is abstracted and travels through that same 10 gig Ethernet pipe. So you get an abstraction of network allowing for extreme flexibility with respect to your network deployment and network access. Okay, so that's it. Those are the two concepts I wanted to make sure we understood before stepping into the Hadoop specific pieces. And what we end up with our architecture is essentially what you see on the right here. On the left is our blade-based chassis, and I include that only for those that are familiar with our UCS Blade server environment, and that's what we came to market with originally back 5 years ago. That's the architecture you see on the left. On the right is what we are talking about here for Hortonworks and for Hadoop, which is a rack mount server with internal storage connecting into that same fabric. What this does show, though, is that if you need both kinds of server, you can absolutely deploy and manage them in exactly the same way. So you might have blades running your Oracle database on a SAN right next to a rack or 2 or 3 of rack mount servers running Hadoop, right? And it's all essentially managed and controlled in the same fashion. Sorry, I'm not advancing here for some reason. Come on, click. There we go. All right, so specific to Hadoop, how do we scale? How do we? Because that's what Hadoop's all about at the end of the day, right? Is being able to handle this big data problem and scale out. We begin with a rack of 16 servers, 16 2RU servers, with a pair of fabric extenders at the top of the rack, and then the initial pair of fabric interconnects, right? So the fabric interconnects are that central management and switching location for the what we call the domain, right? They define the domain. As we add racks of 16 servers, all we're adding at that point is the servers themselves, and then 2 fabric extenders at the top of racks, at the top of each of these additional racks. They attach to the fabric interconnects. That provides a really seamless scale-out model for that pair of fabric interconnects, going out to 10 racks, 160 servers. That's north of 7 petabytes of raw storage, by the way. So that's a massive amount of data. But we have a lot of customers that have gone even beyond that, and that's a big number, but we do. And in those cases, we can connect multiple domains together with another layer of switching, a spine layer, if you will. I've left that intentionally somewhat vague with my little cloud layer there, because the exact switching environment you might use at that layer will vary from environment to environment. Those again, these are pretty big clusters when you're into the multiple domain model on the far right. And if you're at that level, please come talk to me or your Cisco rep, and we'll work with you to figure out what that right switching layer is for you. Okay, so that's our ability to scale out, and as we do so, we want to make sure we're maintaining linearity. As Ajay said, one of the key facets of Hadoop is its ability to scale linearly, and that's the software is certainly capable of that, right? But you want to make sure the hardware keeps up, all right? It's not a guarantee that you get linearity as you start building this out. So we wanted to make sure we were achieving that, and sure enough, we did. We've been running the Terasort benchmark for years now as a way of ensuring that as we add nodes and grow or add data, with the kind of equivalent concepts there, you're able to maintain linearity. So we've demonstrated that over and over. But let's get into the specifics of the management benefits that I referred to earlier with the service profile. So Ajay spent some time explaining how well Hadoop heals itself, right? How fault tolerant it is as an architecture, and has a sort of self-healing capability, and how you don't have to panic when you lose an individual node. You can kind of let it die and fix it at your leisure, and that's one of the the beautiful aspects of Hadoop. Something that really caught my attention when I was first getting into the Hadoop space a number of years ago. But there's a difference between its ability to be fault tolerant and your ability to manage a cluster as it starts to scale. And this is where the service profile technology really comes into its own. When you're growing out your cluster, it's easy enough to build a 5-node cluster. Anybody can do that, stand it up, get it running, no problem. And you're basically kind of doing that management work by hand. But as you start to grow and you get to 16 and then 32 and then 64, and it starts to get bigger and bigger and bigger, maintaining a level of consistency amongst those servers in your cluster becomes a real issue. And it can be very difficult to maintain at scale. And you just think of a simple exercise of needing to go out and say upgrade your firmware on your servers in a 100-node cluster. That's a non-trivial exercise to get right. And even small differences in the configuration can come back and bite you. We had a customer that was having some trouble with their Hadoop cluster. They had a real critical business job that would take a number of hours to run, and most of the time it ran fine. Right? Most of the time they'd kick it off, it would complete in their 3-hour time frame, and life was good. But every once in a while, and this is about a 100-node cluster, every once in a while that job would just lock up, kind of slow to a halt. And the administrator would come in, try to troubleshoot, couldn't really see anything wrong, and would kill the job and restart it, and it would run fine. Right, and that's the worst kind of troubleshooting scenario for a cluster administrator. These kind of intermittent problems, right? And so they were kind of blaming it on the code or what have you, and they couldn't really figure it out. Turns out they had one server out of those 100 that was that came up on the network at half duplex network speed due to a misconfiguration, right? An inconsistency. Now you're thinking, well, wait, that's only one server out of 100. What's the big deal here? That's a minor piece of the puzzle. Shouldn't Hadoop be able to handle that? Well, I mean, Hadoop was running, and the job was actually running, but when it was hanging up, what was happening is that the critical reduce process for that job randomly landed on the bad node, on the node that was really slow on the network. So we had all of these other map processes trying to shuffle their data over to this really, really slow node that was receiving on like a, 1200 baud modem, that kind of thing. So the job appeared to have halted. It hadn't. It was still progressing, just very, very slowly. So that kind of small inconsistency in a cluster can come back and cause headaches, and that's what these service profiles prevent. Effectively, you create the template for the cluster once, and you deploy it across all the nodes. And if it comes time later on to change something, you can make the change in the template and push it back out, and you're guaranteed that everybody receives that proper identity. Okay. And I'll give you an example now. So that was the first technology. That second technology is the Cisco VIC, the virtual interface card. And that is what I'm going to demonstrate here, where we have essentially the ability to create as many network interfaces on any given node in the cluster for whatever purpose we might need. And in this example, I'm showing 3 different network interfaces on every data node. The first VNIC 0 being a management interface, so you can have a separate management network for your sysadmins to be able to come into the boxes, and you can provide separate access to those sysadmins, maybe firewall that off differently, however you want to do that. Second would be the typical, in VNIC 1 here, the typical HDFS internal network for Hadoop, that kind of backbone for the Hadoop traffic. And then third, VNIC 2 showing a network for ingest and egress. So for getting data into and out of the cluster. And so being able to have this kind of capability without having to purchase additional NICs, additional cables, additional switch ports. I mean, we'd love to sell you additional switch ports, right? We're Cisco, but that gets very cumbersome and is not very cost effective. This technology avoids that problem. Can even avoid the need to build out a layer of gateway servers. A lot of times the reason customers have gateway servers in a Hadoop cluster is to act as proxies between the cluster itself and the external world, because you don't typically want to expose the Hadoop network to everybody else. Well, here you don't have to. Right? You got that kind of flexibility. And once you have that type of separation, you can do all kinds of great things with UCS Manager. For example, simply applying quality of service policies to those different networks. It's a click of a button. Right? You do it once in the template, and everybody gets the right answer. Right? You don't have to worry about it. Another example might be enabling jumbo frames, which is typically recommended for that internal Hadoop network, because you're often dealing in that network with large block flows across the network. Jumbo frames are very advantageous. However, jumbo frames, it doesn't take much to screw it up. You've got to have every server in the cluster properly configured on the operating system side, so on the NIC side, and every port on the switch configured properly to accept the higher frame size. And you get any piece of that wrong, and bad things start to happen. You start tearing your hair out. Again, one click, done. Set jumbo frames on or off within UCS Manager, and the cluster's ready to roll. Okay, last example there on the network side, and this is with a heterogeneous use case, which is something we're seeing more and more these days with Hadoop. You know, Hadoop 1.0. You go back 2-3 years, and it was pretty vanilla. It was MapReduce all the time, every day, right? Batch workload type of stuff. But these days, with Yarn and with technologies like HBase and so forth, Spark and Tez and those kinds of things, we're seeing a lot more variety in the types of applications running concurrently on these clusters. And so we set about to test that and say, all right, what if we're running HBase and MapReduce on the same cluster at the same time? Can we get some benefit from the network side of the house? And the idea was, okay, let's set up what you see here on the graph. Let's set up a test where we measure the read latency from HBase clients. And set up a read workload there. And then we kick off a Terasort job, a MapReduce job on that cluster, and see what impact that has on that read latency. And as you can see in the red line there, it's got a pretty significant impact. It causes a big spike in read latency when that job runs. Now we reran that exact same test, but this time we turned on quality of service at the network level and favored the read clients, the HBase clients. Reran the test, and as you can see, we significantly mute the effect of that Terasort job when it runs simply by favoring the smaller packets going out to the HBase clients. And then the bottom graph is a buffer utilization graph where you're seeing basically the deprioritized traffic being buffered and the prioritized traffic in red at the flat line at the bottom just being passed right on through the switch. So these are the kinds of advantages you gain when you have control over the entire infrastructure, not just individual servers, but the network and the servers and the storage all working together. Okay, and I just want to conclude with the, sorry, why is that not advancing? There we go. With, again, reinforcing that concept that basically use the right server tool, so to speak, for the job. As Ajay said, Hadoop is unlikely to displace a enterprise data warehouse or a transactional OLTP relational database system. And those classic enterprise applications, like you see on the right, they're very well suited for a SAN environment with Cisco UCS blades. And doing what they do well. What we're offering is basically the ability to incorporate the correct architecture for Hadoop, which is individual rack mount servers with internal storage, into that same enterprise class management environment, and do so seamlessly where you're basically, as an administrator, administering profiles for the individual compute nodes, and you're not really so worried about the nuts and bolts at the physical level. And we can do it all in the same domain if you need to, or spread it out, but the idea is the management model is consistent across both. And with that, I want to conclude and say thanks again to the Hortonworks team for giving us some time to come and share this with you. And I guess we have time now to move over into the Q&A portion. And I think there's been some, I've been kind of trying to keep an eye on that. There's been some good questions popping up in the panel. So, excuse me. So, Kim, I don't know if you want to field those, or how do you want to do the Q&A exactly?
Yep. Let me look through the Q&A again, but before we kind of get into the Q&A, there's a couple of housekeeping questions. Folks, this webinar will be recorded, and the presentation of the slide will be available on our website at the end of this week. And you guys will also get a nice personalized email from me directing you right to the recording, so you don't have to go and search. A couple questions that came in for both Ajay and Sean. Let's kind of get the beginning of the presentation out of the way. Ajay, if people want to get started with Hadoop, like, what is your recommendation to go down that path?
So that really depends upon where you are in your evaluation of Hadoop. If you're just trying to understand its capabilities at a small scale, I would strongly recommend for you to just start with the Hortonworks Sandbox. It's a single node VM with all of Hortonworks Data Platform pre-installed, and it comes ready with lots of tutorials. So if you're that early in your evaluation of Hadoop, you don't want to be setting up the hardware infrastructure. You don't want to necessarily be going through the efforts of installing Hadoop. Picking up the Sandbox gets you Hadoop ready to go and with tutorials to ramp up. Once you go beyond that, right, once you have the basic grounding of what Hadoop is capable of, and you're starting to look into prototyping your initial use case, that's when I would strongly recommend for you to look into setting up a physical infrastructure for your Hadoop cluster. And typically, we would recommend that you should do it at least a half a rack scale. So if you are at that next stage of doing prototype and pilot work, do it at the least at a half a rack scale, and optimally at a rack scale. Now, that having been said, I know that for some of you, even getting half a rack is not always easy, in which case you can get it at a smaller scale, but to get a good impression of what will be the performance, I would recommend to go with at least half a rack.
Great, thank you. And I see this question is either for you and for Sean and Ajay. Let's go with Sean first. When designing clusters, how much of a factor is it match hardware specification? For example, if I have a cluster with 5 servers, is it a big no-no to have each machine to have different amount of RAM or processor, or should it be all the same spec?
Yeah. So
yeah. Oh, go ahead. Go ahead.
Sean, you take it, and then I'll add to what you say.
Sure. Yeah. The answer is Hadoop will run on darn near anything. That's one of the beauties of it. You can have heterogeneous, homogeneous. It'll run, and you would basically adjust accordingly to this individual server how many processes you're going to run on that specific server. So a server with fewer cores and disks, you would have fewer slots typically for work. Generally speaking, though, I wouldn't recommend that when you're first starting out, at least. You probably, going back to my comments about trying to keep some consistency within the cluster, I would start with a cluster that's fairly homogeneous at the beginning if you can. It is not that you can't make changes to that as the cluster grows. You certainly can, but you'd be inviting some headaches when you're just starting out with some heterogeneity there.
Yeah, I will second what Sean said here. Especially when you're starting, you should shoot to have a homogeneous cluster, and at scale of 5, that should be achievable, right? It will be easier for you would not have to maintain multiple configuration profiles, which is what you would have to do if you had heterogeneous clusters. It'd be much easier for you to debug any performance issues that you're having in your cluster. So yeah, definitely the best practice is to begin homogeneous cluster. Now, beyond certain scale, being homogeneous is almost unachievable because the server specs are changing by the month, if not by the year, definitely by the year. And at that scale, maintaining a few different configuration profiles is very doable. But at small scale, especially if you are starting your experience, go homogeneous.
And to Ajay's point there, one of the beauties of that service profile technology that I spoke of is exactly this issue. As your cluster grows, almost invariably a new server model will come out, or you'll introduce some heterogeneity, some skew into the model of the cluster that's in the server that's in the cluster. And with the service profile technology, it's a piece of cake. You take the existing profile for the original server and you modify it slightly for the new model that came in, and you're done. And Cisco, the UCS manager makes that very easy to do. And then you have simply 2 templates depending on the type of physical server involved, or 3, or however many different servers are involved. But the consistency is maintained amongst them. The only real differences are going to be like the number of cores in the box and the amount of RAM and that kind of thing. But that's trivial from the hardware management side.
Great, thanks you guys. And this is back to you, Sean, based on the use cases you provided throughout the webinar. How many gateway nodes would I need in a small cluster if I want to get started?
In a UCS environment, 0. You don't really need a gateway node. There isn't, in fact, the notion of a gateway node isn't really, the concept of that is kind of a external to the idea, to the world of Hadoop. I mean, in core Hadoop, there is no real notion of a gateway node. Gateway nodes are kind of a de facto standard that's evolved in the Hadoop space because of the problem I described earlier, where generally speaking, you don't want to expose the cluster network to the entire world, right? So you want to have some kind of proxy system so that only certain external clients are allowed to write into and out and read from the cluster, and that's where this concept of a gateway server has evolved. But the reason it evolved is because in traditional architectures, you're limited to one network on the box. Because you don't have any other technology really to allow for multiple networks without paying through the nose for additional NICs and cables and so forth. That we turn that concept upside down, right? We say, well, why not? Yeah, it's free, effectively. Just spin up in software, spin up a separate VNIC, separate network, separate VLAN. And maybe then you don't even need the gateway servers. You might still do it for other reasons, but not because your network's holding you back.
Great. I guess this is both for you, Ajay and Sean. Does Cisco Hadoop use a tool like Puppet to configure server cluster with Hadoop? Can Puppet scripts be tuned to various of the configuration for performance tuning? Sean, you want to take that first?
Yeah, sure. So one thing I didn't get into with the UCS Manager software that runs in the Fabric Interconnect is that it runs on top of a wide open XML API. In fact, the GUI that we ship with the UCS Manager product, the Cisco GUI, itself runs on the exact same API that everybody else has access to. It's just our implementation of a GUI on top of the API. But you don't need to use our GUI if you don't want to. If you want to hit the API itself directly, you're absolutely capable of doing that. And many partners have built tools to do that, management tools that directly address it, bypass our GUI entirely. You can do it in shell scripting. With if you're a PowerShell person, you can. There's some great libraries out there for doing that kind of thing. And if you're a Puppet person, you can certainly use Puppet to communicate with that XML API and basically execute or query whatever you can do in our own GUI. So yeah, no problem.
Yeah, and the same holds true for the Hortonworks Data Platform. Our management wizard is Apache Ambari, which is open source, 100% open source, done at Apache with collaboration of many companies. And Apache Ambari, again, provides you with a UI that you can use to manage your cluster, but it also provides you with REST APIs. So it's really simple to integrate the REST APIs of Ambari into your Puppet and or Chef scripts, and manage the whole Hadoop infrastructure via your preferred tool of choice.
Great, and I think we're running out of time, and I still have a lot more questions. So what we're going to do, folks, is go through your questions, and we'll reach out to you personally to provide you answers to them. But before we go, Sean, a couple of people brought up a couple of things. What was the URL you mentioned to get the validation configuration?
Yeah, I put that out in chat. It is cisco.com/go/bigdata. I may have misstated that earlier, but it's in the chat there.
Okay, great. So, folks, it's cisco.com/go/bigdata. With that, I would like to thank Sean and Ajay for their time and you guys for participating. Again, the deck along with the recording will be available on our website, hortonworks.com/webinar. At the end of this week, you guys will get a nice personalized email from me to direct you to them. And I hope to see you all in the next webinar we have together. Thanks, everybody.
Thanks a lot. Take care.
Thank you.